That's good as well.
Hello. Hello.
Covered in letters. Yeah, that's not distracting.
Welcome to the August 2014 meetup. Thanks to Possible and Gen B for hosting the location and also the pizza later on. There's still people coming in to enjoy the location. We've got 2 talks tonight. One from Ricky, and it was going to be Sam as well, but he's sick unfortunately, and Daniel Hall. So one's going to be on search, and the other's going to be on Google and light bulbs and all kinds of stuff. So that should be good.
So there might be a giveaway or two tonight.
Yes. More light bulbs.
So get this little talk about
Possible. Anyone know about Possible?
Yay! Yay!
So tell us what Possible.
Hi, I'm the digital advertising and content coordinator here at Possible, and I saw you guys tweet. Yeah, that sounds awesome. So we're a crowdfunding platform based here in Melbourne, so this is our office where we all work. We are also based overseas as well in China. But yeah, this is what we do for a day-to-day job at the moment, which is awesome. So we just help creative projects get off the ground. We offer one-on-one advice, and we have chat functions and everything online. So we basically coach people through the crowdfunding process to get their ideas started. We are predominantly film art and performance are our biggest categories at the moment, but we are seeing a big influx of tech coming through, which is why I was really excited because we are expanding to China and getting all these cool projects coming through. So yeah, if you have any questions, possible.com or at Possible. I'm always on Twitter, so you can always do it right there.
Thank you.
And shall we have a quick
Well,
yeah. But our pizzas tonight sponsored by these guys, so tell us what you do.
Right, so my name's Sean, I'm one of the directors from Gen B. Craig over there is the other director. We are mortgage brokers that specialize in working in the IT industry and IT sector, so pretty much helping IT professionals, IT contractors get home loans, investment loans, restructuring existing loans. As a mortgage broker, it's not our own money, we work for the bank, so generally speaking, we can work with your bank to get we obviously have to support the industry and likewise looking for your support back. So anyone who's purchasing a property or has any colleagues that are looking to purchase a home or investment property or looking at a better rate for existing loan, please give us a call and we can organise a chat. We're based on Collins Street, or we do Skype interviews as well, if that's easier. So let's get in contact. Thanks. And enjoy the pizza later.
We might get in first as well, whenever you're ready.
Wait, can I just point out the screen down there, the lighting's all backwards. On that thing down there, which I think is the projector that you've got on the screen.
that's the Google Hangout thing. Yeah, that's live. So
you're recording.
Invert someone who actually. It's so that you're
Sure, whatever you like.
But the letters are backwards.
Okay, so as stated, the ops guy that was going to do the first half of this talk is really sick at the moment. So I'm a dev, and everyone knows that dev can do ops stuff anyway, so that's fine. And I also don't have any speaker notes because this is a new laptop and it's not working, so that's great. So Info Exchange, where I actually don't work anymore, but that's okay as well. So Info Exchange is a not-for-profit. Our motto is technology for social justice. We've been redeveloping our flagship search product. So we basically work with IT to help community organizations empower themselves and to help, homelessness situation, all that sort of stuff. So we have a really tight budget. We have 20 custom web applications that we develop internally, 300 plus CMS sites using Drupal and stuff like that. Get about 4,000 to 8,000 requests per minute, so it's not huge, but it's also definitely not small. There's a whole lot of complexity in just 20 hosted applications being all completely different. So yeah, we have an e-referral application used to send healthcare stuff between hospitals, doctors, specialists, that sort of thing. Electronic waitlist, which is used for aged care management of who gets what packages in aged care. Service coordination between to help a whole lot of people work together in the not-for-profit sector. We do health project management, so when you're organising projects and trying to figure out what you actually want to get out of it. Patient management for homeless people, trying to figure out what's the best course of action for people. Content management, websites, that sort of thing. Yeah, so we encompass mental health, aged care, welfare. Yeah. So we actually established first searchable directory of electronics. First electronic directory of services in 1990. So that included just basic name search, keyword search, regional maps, vacancy search. And to put that in some sort of perspective, 1990, that's Archie, the very first search directory ever on the web. So at about the same time as the first search directory, general search directory ever, we had a server search directory. Before that, to remember Archie. Well, I'm not old enough to remember it, but I'm old enough for Wikipedia, so. And 1991, this is what our service seeker looked like. The 1991 was a BBM system, but this is the legit web version. And as you can see, it's got search for things in various different regions. So, yep. And 1995, so 4 years after we had our service directory, Google came out with their first public thing. So yeah, 4 years before Google, goes. And 1996, apparently that is almost what it looked like back in the 1996 era. This is what it looks like at the moment, but it's only undergone a few small makeovers. And not a whole lot has happened to it since 1996. And this is our new one from, probably not what it looks like exactly today, because this was a little while ago, but so now it is a full API with just a 100% JavaScript front end. It's all a RESTful web service that handles everything. So from the ops side, pretty heavy Debian shop, use Puppet across the board. Recently started doing a whole lot of Docker stuff, so all of our new applications are on Docker. Big fans of Nginx, Kibana, Zen Server, everything runs on Zen Server, Postgres, GitLab is excellent and has BTRFS, which has a fantastic logo. But yeah, so it's a pretty small ops team. I think there are 4 of them. Already forgotten. Yeah, so 4 people in the ops team, so there's not really a whole lot of room to move in terms of your BAU and everything, and it's difficult to get stuff through. Quite slow sand performance, basically got a pretty entry-level SAN from what I've been told. That's not excellent. Limited hardware resources, again, tight budget, so there's not a whole lot of room to just, we need more performance, buy a new server, you've got to tweak the hell out of things and get it working. So we don't really have any search experience either in the ops side or the dev side, and we used Elasticsearch, so we've got limited Java experience as well. So yeah, so we had lots of technical debt. Definitely getting that down very, very quickly. The more technical debt we eliminate, the quicker we're able to eliminate more. Recently replaced our entire network, so that was a problem. Not anymore. That's come with its own little interesting things, which I think I'll cover on later. So our strengths, we're basically able to use whatever modern tech we want. We're not we don't have this whole environment that we must conform to. Debian is a choice that the ops can use. If they wanted to use something else, they could. But, so yeah, BTRFS, Docker, ZRAM, kernel 3.14. I'm sure by now it's not kernel 3.14 anymore. Oh, okay, already looking at Jesse, sure. Yeah. So strong DevOps and Agile practices. We sit next to each other, and although there's a clear separation, we definitely can collaborate with each other on pretty much everything we do. I don't think there's a day that goes by that Dev and Ops don't talk for most of the day. So there's no bureaucracy. Again, if we want to do something, it just happens. Whether that's sort of we just don't tell them about it and it's easier, but there's certainly, if we want something to happen, most of the time we'll get managed to buy and in fact we can do it. So open source, everything is open source. I don't think I can think of one thing that we have that is not open source from the ground up, except the applications. That's ours. So the newly deployed network, that's excellent. Got huge 10 gig backbone which handles all of our Elasticsearch just absolutely fine. Yeah. So the most important thing is hardworking, passionate people that really, really like to make excellent applications and that like tech and everything about what we do, including obviously the not-for-profit side is helpful there too. So yeah, there's a whole lot of stuff that we have. Probably coming back to what we want to do, we do it. We're starting to pay that down and consolidate it, but yeah, essentially we got a lot of technologies in the mix there, and that makes things a little bit more difficult. So as far as the Elasticsearch hosts go, they are running in 3-node clusters. I think Sam mentioned a little while ago that our data center is running a 5-node cluster now, but I could be wrong about that. So yeah, running Wheezy is the latest Debian. The CPUs aren't huge, they're not great, but they're definitely doing everything that we want them to, and not small. So as far as RAM goes, again, it's not huge. You get some people that go with ridiculous amounts of RAM in their Elasticsearch servers, but yeah, 10 gig is enough for us at the moment. So Zen Server 6.2 and Linux kernel 3.14, yeah, it's all pretty new stuff. So let me see if I can remember exactly what all of this means. Basically, you set your heap size to half of the available RAM. That's a reasonably standard Java thing, but because you're running Elasticsearch just as the only application on the server, you don't want to have it standing in your Java heap because it's going to happen anyway. After shard recovery, basically there's a problem with Elasticsearch if you
don't bring up all your cluster at once.
Well, not if you don't bring up your cluster, but if one of them goes down and then it has to come up, then it's got to replicate all of your data at once to the new shards. So yeah, you basically rate limit how fast it can recover, because if it recovers too fast, then your whole cluster will fall down. So those aren't default parameters because well, most people might want it to recover as fast as it can, but yeah. But that is a very good thing, otherwise it can really, really block up everything. So you really, really don't want Elasticsearch to swap, because everything is done in RAM. You would prefer Elasticsearch to just die on the spot than swap, because at least then it's failed, your application will handle a failure and it's not slowing it down. And slowdowns are, in this case, worse than actually just dying completely. So this disable delete all indexes. Essentially, there is a endpoint in Elasticsearch that means that you hit that endpoint and all your data is gone across all of your cluster. So that comes not by default, but you can disable that pretty easily with one line, and that is a highly recommended thing to do. You can still, do a bash thing and iterate through all of your indexes and drop them all one by one, but if you're doing that, then you're pretty freaking malicious. So I mentioned earlier that the new network had its own set of problems. If you're using Juniper routers in particular, this was our problem, that the kernel keep alive timeouts were greater than the router timeouts. So we were having problems where our application just lost connections. And that was because our routers were saying, no, that's gone now, and just cutting it halfway through a connection. Took a very, very long time to figure out. So if you're doing Elasticsearch stuff, then make sure that doesn't happen, because it is a bitch. So garbage collecting in Java is a pain in the freaking ass, especially for Elasticsearch, where you submit something, you want it to respond within maybe 3, 4, 5 milliseconds, something like that. Now, garbage collection, we were seeing 40 seconds, just randomly sometimes, and that was because Elasticsearch doing everything in memory, and it was garbage collecting on when we hit it. So it does that, stop the world, and then you get timeouts and everything is awful. So essentially, what you want to do is garbage collect more often, so you see more of a hit overall, but when that hit occurs, it is in the order of 2 seconds as opposed to 40. So much, much better to do it more often so that you see, it's quicker. And there's the basic, there's a regex that you do across the Elasticsearch init file, I think, to change the garbage collect frequency. So monitoring, we're very, very into monitoring that info exchange. So this is Elastic HQ. It can give you a whole lot of metrics on how your Elasticsearch cluster is performing overall. And you can see here that there's something wrong with the refresh interval. And it tells you sort of things that what that means. So it says high values indicate slow I/O. In that case, if it's red, you can hover over it and see, oh, well, that's what the problem is, and just fix it, hopefully. But other than that, you can see everything's green, you're all good. So Elasticsearch and Marvel, again, amazing insights into how your Elasticsearch cluster is performing as a whole. You can see the average query time, that sort of thing, and it's all live and fantastic. And it's all built on Kibana, which is a logging platform. Sorry, these are Sam's slides. I haven't memorized what's on them, but. It creates really, really big indexes. In the case of our index, I think they got to a few gig a day, which is quite large when you consider that our search index is I think it's a gig and a half or something. I don't know. Anyway, our search index was smaller than our Marvel index. It was worth it though. And it doesn't clean up after itself. So you get days on top of days on top of days, which is a problem considering they're so big. So you need to clean up, and it's no longer free. but it's free for devs, so you can download it, do all your dev stuff on it. It's not that expensive, it's like $50 or something, so it's worth it. But essentially on the doesn't clean up after itself, you'll need to just go and drop indexes when they're over 3 days old or something. But it's very worth it. It's very easy to clean up after it. So Nagios, I mean, everyone knows about Nagios, right? PNP for Nagios, I can't remember exactly what that does. That's an ops thing. But yeah, you can grab all of this stuff. It looks excellent and it gives you fantastic insights. All of this stuff gives you fantastic insights, but it's just more that you can do with it, and it integrates quite nicely with what you've got already. Check MK multi-site. So you got a whole dashboard, shows you exactly everything across all of your cluster, all of your servers, everything. So as you can see here, everything's all good, and then that's not a particularly huge problem, but it's good to know about it if your clusters are out of sync. So again, more things, you monitor your monitoring. So we have our Nagios sending to XMPP, which ops are on all the time, so they get them instantly. Elasticsearch and Logstash, fantastic combination. So Logstash is a thing to basically aggregate all of your logs, and you can dump them into Elasticsearch. And Elasticsearch is so fast at doing everything that you can filter exactly like Splunk, but it's actually like faster than Splunk. So this combination, if you set it up right, can be excellent. You do need to do a bit more setup. There's not as many pre-configured things, but it's very well worth it. So Logstash. I'm sorry, I don't know anything about what this means. Okay, yeah, that's right. Yeah, so there's a pre-made Logstash module for Puppet, and yeah, that's pretty much all that needs to be in there. And like as you can see, it's grabbing the Nginx logs, and that's all it is. Very, very easy to get onto actually logging stuff to Logstash. Yeah. So when you have a small budget, you need to come up with really, really creative solutions to some quite difficult problems. As you heard with some of the config settings, they are not default Elasticsearch stuff, and people say you shouldn't change them. But yeah, it's well worth getting creative and actually configuring stuff for your environment. So Puppet is actually really, really good for managing both Logstash and Elasticsearch. Like you saw, how minimal that config was for the actual Logstash stuff and getting the Nginx logs in there. Similar is true for Elasticsearch. It works really, really, really well. Yeah, building indexes can be slow. We had quite big problems with this. Essentially, when you're indexing 1.5 million documents and parsing them, doing a whole lot of stuff on them, then that can be interesting and take up a whole lot of resources in just a very short amount of time. But yeah, we'll talk more on that and how we solved it. So split brain in Elasticsearch is something you've really, really got to watch for, because Elasticsearch, you start up a new Elasticsearch server and it automatically finds a cluster, joins the cluster, that sort of thing, which is excellent, and it's meant to handle split brain. Problem is it doesn't. So when it doesn't, you've really, really got to be aware of it. Yeah, there was a particular bug that made that happen. Really, really nasty situation. So monitor for split brain, even though it's not meant to happen. Yeah, the modern OS, the modern kernel, both of them just help so much. The fact that, yeah, you're running kernel 3.14, you get the huge amount of speed performance boosts just from that. Java GC is a pain in the ass, more than Java is regularly. Huge problems with that. Yeah, RAM is cheap. Just buy all the RAM that you can. It's worth it. Even though we don't have a huge amount of RAM in those Elasticsearch servers, we just dumped a whole lot in our servers across the board, and yeah, it's well worth it. there's a whole lot of links there. Obviously, you're not going to be able to click them right now, but IXA.io, this whole presentation is on there. That's not going to work. It's just not. So IXA.io, this talk is on there, so you can go and have a look at all those things. Yeah, so dev parts. This part I know, hopefully. So yeah, as you saw earlier, this was ISS2 and basic rundown of what ISS2 is doing. So we have custom indexing. Indexing is essentially you grab your documents and you say, okay, well, it matches these terms. If you type this in, it sort of looks like that. So stemming, stemming is where you have a word like, I don't have my examples here, but something with ing on the end, and it realizes that with or without the ing and the suffixes, they're the same word, so you can match on them. It does a whole lot of other things as well. That's the most basic example. Keywords and synonyms, so if you type in cardiac, it knows you mean heart, or heart knows you mean cardiac, and that sort of thing, just built in. So area search, which isn't quite geospatial stuff, it essentially just goes suburb, region, state. So it's a very, very basic geospatial search. And ISS3, so we use Django, a thing called Celery, which is a distributed task queue for Django. GUnicorn is our application server that we're using. And PostGIS for all of our lovely database things. We don't have any like Nginx or Apache or whatever, it's all just GUnicorn, and Nginx is in front of that experiment, but it can take. So we use Elastic Utils, which is like an ORM for Elasticsearch, sort of hitting a wall there because the geospatial stuff is kind of difficult and everything's kind of difficult, but Elastic Utils is very, very good if you're doing the basic search thing. And TastyPie, which is essentially a RESTful framework for Django. So the hard parts of search, as we've learnt from our product, are geospatial searches, or just generally geospatial anything is insane, and whoever invented these things, you know, there's standards, but there's not really standards. That's why it's stupid. All of this stuff I will speak more to later on, but so private data, essentially we have things like women's refuges that don't want to give out their address but still want to be locatable, so you can ring them up and say, okay, so I need to come and speak to you. So we need to keep some data private, except where you have specific API keys like doctors, etc., and they can just give out the address. Query strings, actually surprisingly hard. You'd think that would just be built in, but it's not. Keywords, again, you'd think would be built in. Keywords being multi-word expressions, so if you've got heart surgery, that's not going to match on something that says heart surgery, it's going to match on heart and surgery. Suggestions, they have gotten even more complicated since I built this slide deck, so yeah, they're really, 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 really difficult. It's not just as simple as, you know, prefix this. Cascaded data, so we've got organizations, services, and sites. So this building would be a site, the organization would be possible, and the services they provide a possible website, that sort of thing. But we've got to cascade data down the chain, which makes for extremely slow indexing. So we've got this like combination of Elasticsearch and TastyPie. TastyPie is meant to work with Django models, and it's very, very good at that. So if you, it essentially exposes Django models over a whole RESTful interface. And given that our ORM is more the Elasticsearch, the Elastic Utils, tying them together has actually made a really, really nice, just quick RESTful API where you can access Elasticsearch stuff through the RESTful API as you would models, and it's fantastic. I'm going to skip over that because that's awful. So it's geospatial search stuff. there are a whole lot of ways that you need to be able to do geospatial search, because it's all well and good to say, you know, you want a chemist in Sydney, and then you've got the keyword that says in suburb past that. That's good. But people don't do that, so you've got to figure out that in this string here, Sydney is a suburb, and you've got to do a search in that suburb. And you don't mean, for example, somewhere called Sydney Chemist. You actually mean the suburb. No. So there's this thing that we made called intelligent query strings. That's what we called it under the hood. And essentially, all that means is that it parses things like doctor in Richmond. Those ones are easy because you know everything after in is probably going to be a suburb. And you can do an Elasticsearch search to say what does that mean in terms of our suburb data, and then you can remove it and do nice things with it. Near Richmond, so the synonyms for those things. That's where it gets tricky because you don't have a keyword anymore. These are all things that people will certainly do. I know I do that one in Google, and I apologize to Google for it. So Richmond is in New South Wales, there are 2 in Queensland, and there is obviously 1 in Melbourne as well. So you need to be able to say, well, you know what Richmond is, but more specifically, Richmond in New South Wales is this one, not those other 4. So New South Wales spelt long form as opposed to NSW. Now, Richmond Town Hall is not necessarily in the suburb of Richmond. That becomes a huge problem. And Doctor around Richmond Town Hall that speaks Chinese. So now you've got 2 keywords, or possibly no keywords. I mean, they could type Chinese Doctor Richmond, right? So you've got to pick out all of these things, which Elasticsearch can do. You can do a search on all of these things and say, what does this mean in this context? You grab that out, you pull it out of their query string, and then just do a search for doctor, plus extra query for Richmond, extra query for Chinese in the appropriate fields. So Elasticsearch definitely helps a whole lot with that, because you can tell us, you can say specifically what did the user mean for this particular thing. It's just a more complicated example. I'm sure you get the point by now. So this particular thing, I'm going to go over quite quickly. So the case of Dr. Epping or Dr. in Epping, you've got all of your areas indexed in Elasticsearch. So if you take that stuff, you say query the areas for Dr. Epping, it's going to say this matches the area of Epping. You can grab that back into your application, take that out, then you do a search for doctor and the area of Epping and put that back to Elasticsearch and it will handle it. So that's how you do all of those things, including the speaks Chinese. You can say speaks Chinese, what does that mean? Yes. This is a particular problem. I hate this suburb with a passion because blood banks is not necessarily in ACT. They're all over the place. Blood banks in banks. Needles exchange. Now that seems like a reasonably legit thing to search for, but there is a needles in Tasmania. The particular problem with this is that we have a whole lot of local councils that is actually our top search term across our entire directory because they have a static link to a search for needles exchanges on our directory. And we were just searching for exchanges in Needles, Tasmania, which local councils would not like if they're not Needles, Tasmania. The rocks and the rock and all other variations of suburbs that have a freaking rock in it. All of these things are immense, immense problems. You've essentially just got to blacklist them. I mean, you can't handle that. Unless you do some really, really complicated statistics, and we haven't had, we've just went live with this, so we don't have the stats to be able to say, you type in the rocks, you mean a suburb. But you can handle that with things like aggregations in Elasticsearch to figure out, here's what they meant. Keywords, so this is joining those multi-word expressions together to actually sort of say, well, heart surgery means heart surgery, not any type of surgery. So when we encountered this, we thought, how has this not been a problem before for people? How has it not been solved just in the core software? But it hasn't, so we're going to try to advocate against it. New South Wales, for example, needs to be recognised as New South Wales, not new, and things somewhere in the south and Wales, that would be a problem. Allied health services, so there's a bunch of examples here of things. So the way you do that is essentially, rather than, you create synonyms, so you say new space south space Wales, replace it with new _ south _ Wales, and also new NSW and anything else. So essentially you're saying that this term becomes a whole lot of other things, including stuff with a whole lot of underscores. Seems really, really dirty to me, but that's the way you do it, because search.
So,
Yes.
you don't have to go through your query logs and sort of build this stuff manually.
No, not exactly. So our product manager for this particular product has been doing it for, how old am I? 26 years. And she is very knowledgeable in the types of things that people search for and how this all works. So this kind of stuff has been in our old product, and she's built that list manually over 6 years. So
the answer is yes, it takes 26 years.
It does, yes. But I'm sure there are some things like states, and you could probably get like an English dictionary of terms somewhere and just do it automatically. I'm not sure of the quality of doing it that way, but yeah. So suggestions, even Google has problems with suggestions, although this is an old picture, I can find but that is an invalid suggestion. I wonder why there are 13,400 pages.
It's run out.
Yeah, well, maybe, or GeoCities, right? So Elasticsearch has this thing called completion suggester, and that sounds really excellent. Essentially what we're doing is just type ahead suggestions. Start typing, and here's a spelling suggestion, or here's something to complete with typing, etc. But that doesn't work because it's just prefixed. So you have to type exactly what you meant, otherwise it's not going to find it. It's more like if you've got a drop down of tags or something and you know exactly the tag, then it's time saver, but nothing more. So the term suggester, it can do sort of fuzzy stuff. So it can do slight differences in the string that you've typed, so you can misspell like 1 or 2 characters or something, and it will say, well, did you mean this? But the problem with that is that you have to complete typing the whole thing, and then if you've missed a character or 2, then it'll suggest it. But it's bad in the way that the completion suggester is good. Phrase suggester sounds fantastic. Phrase suggester is, you type this query string here, and here's what I think it should be. And that sounds excellent. But it's actually not. Because it suggests things back in your query string. You only want to complete stuff at the end of your query string. You don't want it to just arbitrarily like spell correct a word 5 words ago, right? And you cannot control where in that string it's completing stuff. So Markov chains are actually the thing that SwiftKey keyboard uses, and you can stop looking at that. But Markov chains are essentially given a language structure. What word is likely to come next? So you've just typed this, so your next probable word is going to be this. The way it does that is just reasonably simple statistics. You take we've gone through our language corpus and said that these things go together. The problem with that is you get interesting suggestions that is not legitimate. Unfortunately, without actually having statistics, you don't know that that's not legitimate. But it's hilarious anyway. I think that is probably still in our live product, so you should be able to have a laugh. There's also Alcoholics King's cross-dressing. Not quite correct, but sure. Also probably not fixed. So suggestions are really, really hard. Markov chains, that's pretty much all I can say. Yeah, I spent my last day at Info Exchange just rushing to get what I was working on with that finished, and I had spent months on it. So we were having a huge problem with indexing because we have so much data, generating these Markov chains and doing all of this cascading data up. That was taking just huge amounts of time. If you're running a Django app that has a whole lot of processing behind it, I highly recommend looking at Celery. Now, ops hate us for Celery because it is an immense memory hog. Not because Celery is bad, just because it allows us to use all of the resources. Essentially, all Celery does is, we've got these 500 tasks, chuck them in an MQ, and then we, like all of our cluster, takes a job off the MQ, does it, and it's a really, really nice encapsulated way to do that. So we have all of our indexing doing that, 500 at a time across all of our cluster, and it works really, really, really well, apart from the immense resource hit that the ops have to deal with at midnight. And that also semi-addressed our fault tolerance. So basically, if one of those servers goes down, then the other servers are just going to keep handling it. If it got halfway through, then it doesn't say it's complete until it actually is transaction, so it all just rolls back nicely. It's very, very nice. So that's pretty much it. If you have any questions, which you probably will, because I'm not sure how great that was in terms of information and solving problems, then you're very welcome to ask me them either now or afterwards or whatever you would like. Yes.
Talked a lot about some of the challenges with search terms. Were you just sticking with Elasticsearch, or were you at any point did you go, well, are there other types of databases that will help, such as the graph database or something like that?
We essentially stick with Elasticsearch because it encompasses pretty much, like, I think parsing a query string and then doing, say, a full text search in a database, for example. That's what we do in our old thing, and that's a pretty bad idea. Like, Elasticsearch was made for search, and it's immensely fast, and it has all of these GIS features and everything built in, and it's mostly pretty good. It's just, you've got to solve some interesting problems in a little few weird ways, and I mean, graph databases will probably do what you want it to do, but then you've got to build up your data structure rather than, like, search is quite a mature field, so I think it would take a lot of effort to re-implement some of this search stuff in something like a graph database or a regular database, or yeah.
Have you had your ops team read the Jefferson on Elasticsearch?
Which article?
Affairs Calling Navy series.
I have not.
You want to read it? It's down.
Okay. Team who are still using Elasticsearch.
I'll give you the link. It's a series on database and testing database systems for when they fall over. Elasticsearch, they'll over quite often.
Yeah. Yeah, the one with the lobby.
And I friends of one who got something to shoot next to him.
Yeah.
Yeah, I don't think.
Interesting spot, don't trust anything.
Yeah.
I don't think we've had any particular problems recently. Full reindex takes 20 minutes, so at the absolute worst, we're down for 20 minutes and we have to rebuild everything. But that hasn't happened. We haven't had a situation where we've needed to do that ever. So yeah, recently it has been quite stable. There's been like one bug that's pretty much would have taken down everything if we had been live then, but yeah. So yeah, there's been nothing particularly catastrophic. Maybe there will be in the next few days because I've said that now. That's fine. I don't work here anymore. Yeah. So anyone else? Yep.
Are you guys planning to open source any of the solutions that you have developed to overcome some of these issues?
We've open sourced some of it. I'm not sure how much of the actual Elasticsearch stuff that we've open sourced, but some of our tools around Docker that we've used to develop this we've open sourced. And we've made a whole lot of contributions to upstream projects, so a lot of that's been contributed. Yeah. Okay. That's all.
Thanks, Ricky.
All right, so pizza's on the way. It's due here at 7. So what we might do is deviate from our usual program a little bit and have pizza and then have your talk. Is that okay? Yeah. start. Linux on the desktop.
It had something up before.
Oh,
It only works when you
wait, that's okay. I can fix
The
that.
year of the Linux. Seriously, it's not
It's a solved problem.
It isn't, yeah. I just gotta hit mirror, which is here.
Acer.
We have it now, right? Oh.
Projector.
Oh, there you go.
So that's not Linux, that's the projector.
Yeah, projectors are good. I like your pun.
Yes, I would like to allow that. Cool. The light through the clouds. A little pun.
So that's the standard we've got to live up to.
That's the standard you're going to beat for the light bulb. It does say light through the clouds, but I can't actually talk about future products from LIFX or anything like that, so you're not going to hear a lot about what we're doing at the moment. I promise that when we are allowed to talk about it, I'll do another talk. Today's talk's probably mostly going to be about the two clouds that I've worked with the most since starting at LIFX, which is DigitalOcean and Google Compute Cloud. I'm comparing the two. It's not really a fair comparison. So in your head, compare them to AWS and other cloud vendors that you know. Hi, my name is Daniel. I work at LIFX as of 2 months ago. I've written a book on Ansible. I've written a web app for managing passwords called Radic. If you want to work at LIFX with me, because it is an amazing place to work, there's one of the bulbs over there going nuts. Or not at all. Anyway. My phone just stopped talking to it. That's alright, right?
It's infrared, right?
It's over Wi-Fi, so.
Future.
Live demo.
Yeah.
The Internet of Things.
So just for a record, don't do live demos on random wireless networks that you haven't connected to before. Alright, so that's what you can win as well. And if you work at LIFX, you can just pick them up from the corner of the office and take them home. So yeah, if you want to work here, come talk to me or direct message me on Twitter or whatever you can. And so, I probably haven't gone over LIFX. So we're a small startup. We raised $1.3 million on Kickstarter in the first, I think it was 15 days of our thing, and then we actually cut it off because we weren't sure that we could manufacture enough bulbs to meet the demand within the timeframes we specified. So what we did was we stopped the Kickstarter campaign there and then started taking pre-orders. And more recently, we've got $12 million of funding from a venture capital firm called Sequoia, which are the venture capitalists that funded Apple in the beginning. So very exciting time to be working here. So you should be. All right, which cloud? Everybody has a cloud now. I had a switch vendor. We're doing a fit out in our office of switches. I had a switch vendor trying to sell me the cloud the other day. It's crazy. Most people, when you say cloud, they're yes. Why do you need a cloud? I can't talk about that. At the moment, we have an integration with Nest. If you know about Google Nest, it's a thermostat that you can use to control your house. It actually learns about your habits and stuff, and will turn the heater on at the time you normally get home, and all sorts of stuff like that. Because all Nest servers are in the cloud, and we need to be able to talk to your bulb from them, there will be some cloud stuff. That's all I can talk about now. There are exciting things coming in the future for LIFX, but yeah. Back on to what I was saying. Most people, when you say cloud, they think of AWS and, We learned at the AWS Summit today that AWS have about 10 times the capacity of everyone else together, which makes it fair. But does anyone really check and see what Google looks like, what HP's cloud looks like, or what my random switch vendor who was selling me cloud the other day, what their cloud looks like? And I'd hazard a guess to say most people don't, just because they don't know about a lot of the other clouds. And even if they do check, they probably check one or two. So I'm going to be going over, a few other clouds, and I hope this encourages people to look into what else is available. And also, why do you have to pick one cloud? Why not multiple? Why not pick the services you need from each one? Yeah. So DigitalOcean, at the moment, their cloud consists of every machine runs off SSDs in their computing stuff. Then they have private networking. We'll go over that a bit later. They support IPv6. They're one of the few cloud vendors that does. Linode does as well. They let you manage your DNS with them. And when you spin up a machine, you can choose to spin it up with backups taken every day, although that feature hasn't been entirely reliable, which is kind of annoying for something that is backups. And they also offer a web console that can actually console onto your node, which is something you can't do in Amazon or Google and a lot of those. Google Compute Engine, however, has a lot more services. They have App Engine, which will run your node run your application in a similar way to Heroku, with some limitations. They have Compute Engine, which is just like EC2, basically, raw machines. They have storage, Cloud Storage, which is a blob store. They have Cloud Data Store, which is NoSQL Store, and Cloud SQL, which is MySQL but managed by Google. They have BigQuery, which is for querying absolutely massive databases in an SQL-like language. They have a translation and prediction API. Now, the prediction API is really cool when you're auto-scaling. They have Cloud Endpoints, which is a service for integrating mobile applications with machines in the cloud, either in App Engine or Compute Engine. And that actually comes free with those two. They have Cloud DNS, although that is not covered by any of their SLAs at the moment, so you may want to avoid using it. They have something called Cloud PubSub, which is they call it a low latency queuing/topic system. There are lower latency things out there, but Google's is actually quite nice and reliable. And they have Deployment Manager, which is similar to CloudFormation in AWS. Yeah. Okay, so let's go over and compare the things that these two clouds have in common, because there's not actually a lot of similarities between DigitalOcean and Google because they don't operate in the same sort of space. DigitalOcean's a tiny little startup, and Google's a very big, established, multinational company. So, in terms of performance, Google is going to give you a better performance for your machine. And in most cases, per dollar, the performance is better than AWS, most cases. And DigitalOcean, on the other hand, is incredibly cheap. Like, you wouldn't believe how cheap it is to just have a bunch of machines running in it. Google, their machines start up in about 90 seconds. DigitalOcean start in 55. Google has 15 types of instances, high CPU instances, high memory instances, high disk instances, really tiny instances, whereas DigitalOcean's range starts with a low CPU, low memory, low disk, and kind of just moves up in all three categories at once. Which means if you want high memory, you don't want high CPU as well, you're kind of paying for CPUs that you're not going to be using. Google has 3 regions, US Central 1, Asia Pacific 1, and EU Europe 1. but they have 8 availability zones in there. DigitalOcean, on the other hand, they don't have the concept of availability zones and regions, but they do have several regions in the same areas. So I've collapsed them all and said they have 5 regions, because they have 2 in New York, 2 in San Francisco, and 7 AZs. Google are promising that IPv6 is coming, and they're adamant that it's one of their core things that they're going to get eventually. Whereas DigitalOcean have it now. In terms of networking, Google lets you spin up 5 networks per project. So if you need more, you can just create more projects, or you can file a support ticket with them and say, hey, I need more networks, make them for me. They have the same thing as Amazon. They have a whole lot of quota limitations. There's a page and an API call to get them, and all you have to do is ask nicely to get them increased. There's actually an API call for filing support requests as well, so in theory that could be entirely automated. And I wonder if it's automated on Google's end as well, because they're pretty quick to increase them if you've been with them for a while. So. DigitalOcean, on the other hand, there is a private network in a DC. You share it with all of the other customers. So when you bring up your private interface at DHCPs, gets an IP on the 10.0.0.0/8 subnet, and then you can talk to any DigitalOcean customer in the same data center. So I think when they mean private, they mean a private address range and not actually any other semblance of private. Yeah, so you can just sit there and TCP dump on one of those and watch packets fly past you. Internally, all traffic is free in both Google and DigitalOcean. On DigitalOcean, though, if you talk to another instance on its public interface, it costs you money. Google, on the other hand, it's a lot harder to talk to the public interface, and it's because of the way they apply their IP addresses. So when you start up a machine in Google, you have one interface, and it has a subnet, a private address range that you've specified. But Google also NAT a public IP address on it, which means you can't see that from the instance. It doesn't have that IP on its interface, but it means you can change the IP while it's running. So you can have a bunch of DR servers, and when your prod servers go down, you can pull those IP addresses off them and throw them on the DR servers, and everything just keeps running, which is fairly cool. You don't have to wait for DNS or anything. It just changes in Google's firewall, and bam. Google does a tag-based firewall system. So you define firewall rules, and then you define alphanumeric tags, and as you apply them to instances, it creates the firewall rule for it, which is kind of cool because if you've ever gone to delete a security group in Amazon and it's complained because there was some instance or a random load balancer somewhere on someone else's project that was using it, and you're like, can't delete that now. Whereas in Google, it's all tag-based, so you can just spin up, delete, whatever, apply new firewall rules. And the other thing is the tags are available to the instance as metadata, so you can use those tags with Ansible, for example, to decide what gets deployed on the machine. So if you need more web servers, you can just tag web server on a few of your other spare instances lying around. Ansible will detect that change, install a web server and all that sort of stuff, and Google will update the firewall rules at the same time, which is incredibly awesome. Google has static IPs, which is cool because you can throw them between machines live while the machines are running without rebooting anything. DigitalOcean, on the other hand, you get assigned a random IP when you create the machine, and you don't lose it until it gets destroyed or the machine dies. And yeah, Google, you can change the IP on the fly. You can just throw your IPs around. You can even get a new random IP for a machine if you don't like the one it got. Maybe you hate, the number 42. And in DigitalOcean, to get a new IP, you actually have to completely destroy the machine and then rebuild it. Disk imaging. In Google, you have manual snapshots, whereas DigitalOcean you can turn on backup when you create the machine. You can't turn it on after, you have to turn it on when you create the machine. And that takes a backup once a day of your machine. Google can take snapshots completely online. If you want your disk snapshot at any particular point, you throw a REST call at Google and they'll take a snapshot. DigitalOcean, on the other hand, if you want to take a snapshot, you have to shut down your machine, take the snapshot, and start it up again, which is really hard if you have to migrate from one DigitalOcean region to another because they're having network problems in one region because they had a line card fail in their only router.
Not the obliterate, for example.
Hypothetically. Google replicates their snapshots globally. DigitalOcean do as well, but you have to manually go into the snapshot and tick the boxes of where you want it replicated to, and then wait. Whereas Google snapshots are available from the minute the snapshot is done. You can then create a disk for it in any region. It might take a while to create the disk if it was a fresh snapshot, but you don't have to specify where you want it replicated. Google handles it all for you. And Google encrypt all their data between their data centers and on their disks at rest and in flight. The only thing I believe that's not encrypted is the RAM and the processing state of the machine. DigitalOcean, on the other hand, don't encrypt anything. They don't say that, but we know that because in 2011 they had an incident where you could look at the free space on your newly provisioned DigitalOcean machine and find other people's files. They also make it really hard to encrypt your disk because of the way they provide your images, and you have to use something like TrueCrypt or AnkFS to encrypt things if you want to do it on DigitalOcean. You can't encrypt your boot disk, for example, which is a real shame. They have fixed that problem with the looking in the free space of your thing. Everything's zero now. DNS. So on Google, you can set any TTL you like on a record. On DigitalOcean, there is one TTL for the zone, and you get that on every record, which is kind of annoying. Actually, no. That is utterly frustrating beyond all belief. And until the new API came out, you couldn't even set that TTL. So it was set at 3600, and you couldn't change that, whatever you did. That said, Google, you pay like 40 cents per million queries. On DigitalOcean, it's completely free as long as you have Node running, which, you can't really complain about a free service. Google has, at the moment, an API and a CLI. I'm pretty sure they'll have a GUI in the works before they actually apply their SLAs to it. Whereas DigitalOcean, they only have an API and a GUI, but you could write your own CLI to it fairly easily. There's no charge for API calls, and that actually, on Google, that applies across everything, and same with DigitalOcean. DigitalOcean does rate limit you, and Google do within reasonable things. I think DigitalOcean is something like 5,000 DNS requests per hour, which is fairly high. Google's is even higher, and if you have billing enabled, it's even huger, and if you ask them for more, they'll increase it as well. On Google, when you make a change, the authoritative servers for that zone are updated in seconds. In DigitalOcean, the authoritative servers are updated in about 5 minutes. I have a feeling it's a 15-minute push out, so I think it might be about, on average, 7.5, but I'm not sure. I know in my testing, it was about 5 minutes. Which is another shame, because when you deploy a machine, you don't want to have to wait 5 minutes before you can query that. And if you query that too early and you hit the negative caching, then, well, good luck talking to that machine unless you have its IP. Okay, to conclude, if we use Amazon too much, if this whole industry decides to not look at the alternatives, we're going to have a monopoly where Amazon have everything in compute. And we know what Amazon do with monopolies because we've seen recent cases of what they've done with ebooks. It would be a real shame to not have any competition and no one to push Amazon to actually be better. Amazon lowered their prices when Google lowered their prices. It's actually helping to have these other vendors. So I think people really need to start getting off the AWS blinkers. And it's really bad that I'm doing this on the day the AWS Summit was. But people really do need to take off the AWS blinkers and look around and see, hey, Telstra have a cloud too, did you know? people have clearly tried the Telstra cloud. Yeah.
How about you, Telstra one?
But seriously, go look at what's out there. Go try out Google. Go try a cloud vendor that I haven't mentioned today, and let us know your results. I'm sure Matt and Dave would be happy to hear talks about other cloud vendors. And who knows, almost certainly some of them have some crazy features that are really cool. Like, imagine the prediction API on an auto scaling. Like, how cool would that be if you knew that load was coming and you could scale up for it before it happened instead of when it happens? Yeah, that's it. Who wants a free light bulb? Okay, so I think the plan was to get people who want a free light bulb up here. You have to tell the whole group a lame dad joke regarding light in some way, and the most groans gets it. I've got two. One's bayonet fitting, the other one's screw fitting. If you get one that doesn't support your house,
Change your house.
change your house. You can buy lamps at IKEA with pretty much either fitting and all sorts of lamp stores. So, you know. Cool.
I've got a chronometer here to change it.
Ooh. All right. Come on up.
Should have line checks made lamps. Change that color.
I'll go get it.
So they get hot.
It does. Yes, fairly hot, but I can hold it. I'm holding one.
Yeah.
This is my. Reset it back. That way you don't get Puzzle's Wi-Fi password. Go ahead.
Why is your dad like a light bulb? They both have threads that look like it created in last century. What a bit.
I need at least one other person because there's two balls.
Is that allowed? Googling jokes.
Yep. Thomas Edison's father. Of course I'm proud that you